Okay, well, let's get started. So, bonjour, chers amis. Good day, everyone. I am David Berger, Executive Director of Green Marine. It's my pleasure to welcome you to our sixth and final GreenTech webinar. So today we're going to focus on technology helping the shipping industry on its sustainability journey. It's no secret that we're facing huge environmental challenges, and at times it may seem like an impossible task to change our ways fast enough to avoid the worst consequences of climate change or the decline of biodiversity, for example. Technological innovation is clearly our best ally in that regard. So I believe that the current pace of research, and acceleration of creative solution is really a source of hope and optimism. So that will be the topic today, hope and optimism. So we're going to talk about technological innovation from 4 different perspectives. Our speakers will touch successively on Transport Canada support to R&D in green technologies, partnership to encourage innovation in the state of Washington, energy storage and efficiency on board ships, and hydrogen enhanced fuel. And just before we start, allow me to thank once again our 14 sponsors, and especially our gold sponsors, FedNav, Groupe de Gagny, the 2 St. Lawrence Seaway Corporations, and Ken4Nav. As mentioned before, we're extremely grateful to those sponsors who maintained their support despite the cancellation of our conference back in June. Thanks to their support, we're extremely pleased to offer this webinar series free of charge as an alternative. Now, before I give the floor to our speakers, let's review very briefly how this webinar will work. So we have 4 speakers. They each will do a 15-minute presentation. After each presentation, we have a 5-minute question period. You can ask questions, of course, anytime using the Q&A feature located at the bottom of your screen. You will be able to see the questions asked by all attendees in the Q&A box. We invite you to read them and upvote your favorite ones by using the like button. Even if we don't have time to answer all questions, the speakers will continue monitoring the Q&A box and they can type answers during the webinar. Manon Lantier, our communications manager, will be monitoring the technical side of the webinar, while Thomas Gregoire, our East Coast and Great Lakes program manager, will be handling the PowerPoint presentation. So let's get started. Our first speaker is Abigail Fyfe, Senior Research Development Officer at Transport Canada's Innovation Center. Abigail studied in naval architecture, and before her current position, she has spent about 13 years with Transport Canada as a safety inspector and about the same amount of time with the Transportation Safety Board as an accident investigator. She's currently part of the team working on the development, implementation, and management of the research program focusing on marine mammal protection issues. So Abigail, on that, you have the virtual floor.
Thank you very much, David, and thank you for inviting me to join this conference today. As you mentioned, I'm going to speak to you about Transport Canada's role in supporting innovation for a greener maritime sector. Transport Canada is obviously just one part of the federal government, or one portion of the federal government family that is also supporting innovation. But I'm really pleased to be here and to describe what we've been doing, what we plan to do, and to give you some examples of the kinds of things that are underway right now. So please, let's switch to the next slide. But before we go into all that, I'll start by just introducing the Innovation Center a little bit. We're a fairly new organization within Transport Canada. We were formed in 2018 in our current form. It's not that research wasn't being done in the department before, but in January 2018, all the little groups that were funding research, there was an effort to consolidate them under one umbrella as part of the Transport Canada Innovation Center. As such, we're a multimodal group. We address issues on the on-road sector, marine, aviation, and rail sectors. And our primary focus is to support the various mandates of Transport Canada, which is a regulatory department, in its mandate to decrease the impact of transportation on the environment, which is the particular interest of this workshop today, improving safety and security of transportation, and improving the efficiency of transportation systems in Canada. So we'll go to the next slide. So specifically, our Marine Research and Development and Demonstration Group, we're a group of engineers. We have excellent policy analysts, which is a key element of our team to keep us in tune with the policy organizations within the department, to make sure that the work that we're doing is relevant to their objectives. Myself, a naval architect, and we have a marine biologist on our team. The term marine research, development, and demonstration might not be familiar to most people. Most people are used to just research and development. We added the second demonstration, the second D, to highlight the fact that the type of projects that we support go beyond fundamental research and go beyond just research in and of itself. And we also look to fund projects that are supporting technologies at a higher TRL level and demonstrating those projects in the industry and seeking to ascertain feasibility of technologies in operational situations. So that's the primary purpose behind the demonstration part. Right now, the Marine RD&D group is focusing in two main areas. The first is advancing clean marine technologies, specifically those that are aimed at reducing the air emissions from marine shipping in Canada. And second, to protect Canada's at-risk marine mammals from physical disturbances and acoustic disturbances, both of which are associated with vessels. And we'll go to the next slide, please. So just briefly, I'm sure most people are familiar with the elements in the transportation sector, the marine transportation sector, that are driving initiatives to clean up marine shipping. Right from the bottom up, purely from a fundamental level, ships emit quite a bit of CO2 and other greenhouse gases into the atmosphere, and therefore have a role to play. Shipping has a big role to play if we want to protect the planet from the effects of those emissions. But on a more regulatory or policy level, the International Maritime Organization has set goals and standards for CO2 and greenhouse gas emissions reductions by 2050 and then by 2070, or sorry, by 2030 and 2050, they have set significant reduction goals. And following from that, Canada on a domestic level has also implemented regulations and goals for emissions reductions. Most significantly, by 2030, we're aiming to reduce GHG emissions by 30% below 2005 levels. And to get us there, we need to make, everybody I think is aware that we need to make some significant changes in the sector. So we'll go to the next slide. The second area of our research program that I mentioned was marine mammal protection. Unlike the air emissions drivers, the drivers for our marine mammal protection goals are not associated with specific regulatory policies or international goals and regulations. With respect to physical and acoustic disturbance from ships with marine mammals, there have been no specific goals set for reduction. And we're really starting on the ground floor in a way with this issue. Marine mammals use noise and acoustics for a lot of their key functions, socializing, mating, navigation, hunting or finding food. Humans and ships emit quite a bit of noise into their underwater environment. And the risk of that is that they can mask the acoustic signals that marine mammals use to survive. There are behavioral responses to underwater noise, and the underwater noise in their environment can just cause physiological stress on the mammals. All of these have been identified as stressors to the survival or the recovery of specific at-risk species in Canada. We'll move to the next slide. This is kind of highlighted here. What I'm showing here on the left of the screen is a chart which basically the dark blue lines are depicting the shipping routes into Washington State and the Port of Vancouver and Victoria through the Salish Sea on the west coast of Canada and the US. And on the right, we have a noise map. This is a monthly average noise levels in the same area. And you can see, and it's probably not a huge shock, that the intensity of those noise levels follow very much the same tracks as the ships. And on the left, what we're seeing there in the green and the blue is some of the critical habitat of the southern resident killer whale, which is an at-risk species on the west coast. So putting these two side by side, we can clearly see that the increased levels of noise from shipping in the Salish Sea are directly overlaid on the critical habitat of the southern resident killer whale. This just highlights the need to have an impact to mitigate the impacts and mitigate or reduce the amount of noise that is being emitted into their habitat. So we'll go to the next slide. So with that in mind as a background, Transport Canada has received, or we have funding available to us, the Innovation Centre has funding available to us to support projects which are going to tackle those two key issues. And the way we've been doing that more recently is we've initiated what's intended to be an annual request for research projects, an annual request for proposals. This annual request is managed or run by Public Service Procurement Canada on our behalf. It's a transparent process open to Canadian participants from the Indigenous communities and otherwise broadly in the marine stakeholders in the marine sector, industry, not-for-profit groups, academia. We've had up to just over 21 million is available for projects under the three streams that I've shown here for the next 4 years. We have one key theme or stream under this proposal, this RFP, which is looking for proposals towards the marine mammal protection goal, another specifically for a clean marine goal, and the third is a combined stream. We've recognized that in some cases there can be links and either co-benefits or not associated with those two goals, or specifically the reduction of vessel noise and its efficiency and therefore emissions. So an area that we're very keen to explore further is trying to quantify those links. We understand that not all noise reduction measures that can be taken on board a ship will also improve vessel efficiency and reduce its emissions. Sometimes the reverse can happen. And so we need to support projects that will explore that further, and that's the purpose of this combined stream that I talk about here. We issued our first call under this RFP last fall. It closed on January 20th of this year. Most contracts under that are currently underway, and there are a couple more that we're still in the process of getting up and running. And we hope to have another call later this winter, maybe early next year. And I'll talk a little bit more about this process and about some of the projects that came out of this call in the next slides. So we'll go to the next one, please. So here I've just shown that our call for proposals, there's our three streams: clean, marine mammal, and combined. Under the clean stream, we asked specifically for proposals that would advance emerging technologies or test and validate pre-commercial and commercial technologies. This is the demonstration part of our D&D. In the marine mammal protection stream, we're asking for projects that would conduct safety assessments and technology scans. We're very interested in the development of models and predictive tools that designers can use at a very early stage in a vessel's conception to reduce the underwater noise from a vessel. And then finally, to test and evaluate technologies. Again, there's our demonstration, the demonstration part of our program. So the next slide, please. This slide here is just basically a depiction of the cycle that this request for proposal will follow. I don't think we need to linger here, but effectively each call will be linked to, or the work that's done as a result of each call will be linked to the requirements that we put out in the next one. So there will be a continuous cycle and continually feed the process. Let's go to the next slide, please. So I have some examples of current research projects. And I'm sorry, I've lost track of my time. If I can have an idea of how much time I have at this point.
I believe you have 2 minutes left, Abigail.
Okay, so we'll have to, sorry.
Sorry about that.
Very quick. I'm glad I checked in because I have I've put out here a brief slide on each of the 10 new projects that we initiated under the call this year. So what I'll do is I'll just quickly go through them. Participants will get a copy of a PDF copy of this presentation. So you'll be able to see a little bit more about each project. Please, next slide. And we'll go fairly quickly. I'll just name them off. Effectively, we have here a marine zero fuel assessment tool by Canadian Nuclear Laboratories. They're developing and advancing a tool to assess the use of hydrogen in the marine sector. This includes port vehicles, to assess its usefulness, cost benefits, environmental benefits, etc. Next slide. Albion Marine Solutions, 1 minute. Albion Marine Solutions is working on an advanced air abatement technologies, barge-based exhaust cleaning technology. Next slide. Hull coating, Algoma Central Corporation is participating in full-scale trials to quantify the benefits in emissions reduction by maintaining their hull. The next slide, please. Vessel fuel optimization, Fujitsu Intelligence Technologies. Please, next. We're supporting Offshore Designs Limited to develop an on-the-go robotic hull cleaner that would be tethered to the ship and is intended to clean its hull in deep water. Next slide. We have a cavitation, this is propeller cavitation monitoring and management. Propeller cavitation being a large source of noise on ships, supporting All Salt Maritime Corporation to develop such a system and assess its feasibility and its effectiveness. Next slide. We're supporting JASCO Applied Sciences, DW Ship Consult, and BC Ferries. They're all working together to do some full-scale trials and experimentation to support the development of an ISO standard for shallow water vessel source level measurements. Next slide. Another shipboard cavitation monitoring system project, this one by JASCO. This one involves full-scale trials with Canada Steamship Lines and also includes a DW Ship Consult as partners. Next slide. The impact of underwater radiated noise reduction on compliance with energy efficiency design index criteria. That's a mouthful. This project will answer some questions that I mentioned about the links between energy efficiency and the mandatory IMO requirements for the EEDI and any technical efforts to reduce noise. Next slide, please. This is the URN and Greenhouse Gas Reduction Program for Canada's inshore fishing craft. Graphite Innovation and Technologies with Lloyd's Register is going to quantify the benefits both from an emissions and an efficiency and a noise reduction point of view associated with applying a new graphene-based hull coating. Full-scale trials involving several fishing vessels. And this is an example of one of those combined projects that I spoke about. Next slide. So it sounds like a lot. That's 10 projects, but that's really just the tip of the iceberg. I didn't even talk about some of the innovative projects we're working on the mammal detection side of the fence, which is to mitigate physical disturbance and reduce collisions. We're supporting UNB to deploy gliders in the Gulf of St. Lawrence to detect whales or North Atlantic right whales in that area. We're also supporting projects to advance the use of infrared cameras as whale detection methods. Our next call for proposals is expected later this winter or early next year. And just for everybody's information, we also just recently announced a $2.5 million contribution program that's open to Indigenous communities to participate in vessel noise reduction projects. That call is open right now. And finally, the next slide is just my contact information, and I'll stop there.
Thank you very much, Abigail. This was a very clear overview of the main project supported by Transport Canada's Innovation Center. I know for a fact that the industry really appreciates the increased financial support for R&D in green technologies in the last few years. So we have one question from the audience. It's from Supriya Tandon from Logistic. Even if there isn't a direct regulation or law that requires limiting noise impacts on marine mammals, wouldn't it be required under HADD limitations in Fisheries Act?
I'm not familiar specifically with HADD limitations. What I can say is that we do work closely with Department of Fisheries and Oceans, who would be very familiar with these limitations and the requirements. In fact, I have to confess, I'm not even sure what HADD stands for.
H must be for habitat, and then I don't recall.
Maybe somebody will answer. So no, apologies, I'm not familiar with those. But we work very closely with Department of Fisheries and Oceans, and I'm absolutely certain that if there were any implications between the two, that we would have been made aware.
Thank you, Abigail. Just a very quick question, and this one is from me. Could you tell us just a little bit more about the response from both technology developers and the shipping industry, companies and ship owners ready to embark on those demonstration projects? Are you swamped with project proposals, or do you need to go out there to really advertise the opportunities?
Well, we put out, we've only been through this process once so far, although we intend to do more in the future. The call went out in November 2019, and the closing date was January 2020. So a very short time frame for proponents to develop a proposal, and over the Christmas holidays. And we were thrilled with the response that we got. The 10 projects that I had described account for about $4.5 million worth of work this year, over the next 2 years, mostly. We fully expect, and in the course of getting those projects started, the connections that the various projects, the connections with projects, different projects are becoming obvious. It feels like it's mushrooming and growing. I fully expect the next call, which we anticipate allowing more time for proponents to respond. And after events like this, where we can speak more about it, and it becomes more real, I anticipate that, yeah, we might be swamped.
Okay, thank you, Abigail. Someone in the audience responded to HADD, explained that it's harmful alteration, disruption, or destruction of fish habitat. There you go.
Thanks for that, whoever put that in.
So thank you again. So let's move on. Our second speaker is Joshua Berger, who is the governor's maritime sector lead for the state of Washington. Joshua works as the liaison between maritime industry stakeholders, the governor's office, legislature, and state agencies. In his director of maritime role, Joshua managed the development of Washington State's strategy for the blue economy for a sustainable, decarbonized maritime industry. He founded Washington Maritime Blue, an independent cluster organization to implement the state's strategy, and serves as the board chair. So Joshua, we're listening to you.
Hey, thank you, David. You can see my screen okay?
Yes.
All right, great. Well, I really appreciate the opportunity, David, Abigail. Great to hear your presentation. Here in Washington State, we share a lot of affinity with the term RD and D. We have a similar fund, a state fund called the Clean Energy Fund, of which we have a specific bucket there for RD and D. So we have a lot of affinity here in Washington State. I will say that still many of us have still a lot of Canada envy. But I appreciate the attention and work that's going into this space. Just make sure my screen's looking okay. My name is Joshua Berger, and I play this unique role as maritime sector lead for the state of Washington. And as well as work as founder and board chair of the independent organization Washington Maritime Blue. So I'm sorry, I'm getting my screen a little bit screwy here, so I want to make sure.
That's where you just have to hit the slideshow at the bottom right of your screen of the image, and then you'll have the full screen for your presentation.
Thank you. Well, you know what, I might give it back to you if that's okay. Thomas, is all right if you go ahead and grab, or here I can get it back. Thomas, okay if I give it back to you?
Yes, Tom will share it.
Thank you. So I'll off a little bit. So what I'm hoping to share today is specifically we'll focus a bit on the Washington Maritime Blue Innovation Accelerator. It was a work that we kicked off just last year. And but hoping to give you a little bit more kind of backdrop to both kind of the state strategy for the blue economy, the work that the organization Washington Maritime Blue does, and how that led to our focus here for this talk today around supporting entrepreneurs and driving capital into this space. We could do a whole nother session on our joint innovation projects, similar to the projects that Abigail was talking about in Canada. So we'll save that for another day, or when the conference comes to Seattle next year. hopefully in person. We'll love that.
Hopefully.
So next slide, Thomas, thank you. So a quick bit of background, starting in about 2017, Washington State and my office, the Department of Commerce, and the governor, we pulled together a Maritime Innovation Advisory Council with the real kind of distinct goal of putting in place a strategy for the blue economy. So looking across the globe and the movement that was happening at that time to have a focus on the broader definition of the blue economy, sustainability across maritime and ocean spaces, but really having a vision of growth in these sectors, supporting marine and ocean health, and then also a focus on resilient and equitable communities, and that being kind of the underlying focus of the state strategy. Go to the next slide, just a quick overview of the high-level goals, its connection back to the SDGs, really inspired by some incredible work, yes, in Canada, Norway, France, Portugal, Ireland, and elsewhere that are really starting to have this focus on this broader topic, the blue economy. So really the first, state in the US to do such. It's great bedtime reading to look at the executive summary, maybe nice Sunday afternoon in your hammock or anchored out in a bay to read the full strategy, and I encourage you to do that. The graphics are fantastic. But as you all know, a strategy is about as good as its graphics and the shelf you put it on if you're not actually implementing it. So next slide, Thomas. As we were completing the strategy and getting ready to deliver it back to the governor and the hundreds of stakeholders that formed it, we went out to and looked at other places around the globe that were kind of already leading in maritime clean technology and renewable energy, offshore renewable energy, and the like, and said, what are your mechanisms for doing so? And we looked at this model of an organized ocean or maritime cluster, an innovation cluster, to be able to do that work under that tenet of that quadruple helix. So ensuring that there is a place for industry, government, public sector, academia research, and in our case with a focus on workforce development and community organizations, all driving forward and working together to move forward those goals that the strategy had set. Next slide, Thomas. In now just the last 18 to 20 months, this cluster organization is now nearly 100 members made up of that same quadruple helix. We have engaged in our everyday work, everything from the large corporates like Wärtsilä, Kongsberg, ABB, as well as our major maritime transportation companies here locally, TOTE, SSA Marine, the terminal operators, Crowley, naval architects, but all the way down to the one-person engineering shops and the startup companies part of our work. Of course, our major research institutions here locally in the national labs, applied physics labs, public partners, everything from state agencies to local ports and utilities, and of course our organizational partners that help us drive this work forward from many perspectives as well. Good, next slide. So what do? We have what we call kind of the 6 blue Fs. I really appreciate alliteration as much as possible. It gets tricky at times, but we kind of work in these core areas. We're a marketing and communications platform for the blue economy just in general, knowing that this is a global effort, but certainly with a tilt towards how we're moving those goals forward for here in Washington State. We host these Blue Forums, so knowledge and networking events on key topics. Blue Forward is where we run joint innovation projects. We've taken many cues from the Norwegians, and with support from our partner and contractor DNVGL, run these joint innovation projects where we bring sometimes a whole supply chain together to do a project, sometimes competitors to help create a standard, or just the right minds in one place to put a strategy forward for, let's say, decarbonizing the Seattle waterfront. Blue Force is our workforce development programming that has a strong focus on bringing youth of color and young women into the maritime pipeline, a series of internships and bringing together all the stakeholders for that to run those programs. Blue Finance is kind of our mechanism to bring access and be a pipeline to all sorts of and the various different types of funding that will impact the blue economy. We'll talk some more about that. We don't run our own fund, but we help drive various different types of capital to our projects. And then Blue Founders, that's what we'll talk about more here today. So Thomas, you can go to the next slide. So we'll kind of focus on that kind of cylinder of excellence around supporting entrepreneurs and bringing capital into the blue economy. So it's really focused on providing startup incubation, acceleration, however that's appropriate. And like I said, we are not in the business, at least at this point, of operating our own fund for these startups or these projects, but be a pipeline to the various different funds that are appropriate. And we'll talk about, kind of we'll talk about how varied that is here in a minute. Go ahead and go to the next slide, Thomas. So we started with a capital landscape study. We kind of wanted to know, all right, this blue economy, first of all, we have to define it. We have to define it for ourselves here in Washington State, how broad and diverse that is. But where does money need to flow, and what kind of money is out there? All these different flavors of dollars. And what we learned, I think, is no surprise that, there's a particular need for early stage capital, those RLs, those new founders. Where is the capital that's actually even just paying attention to the maritime or ocean space? And by the way, venture capital was not paying attention to the maritime and ocean space until real recently. That has really started to shift. We also kind of come with a theory of change that there's lots of opportunity for government and philanthropic grants to de-risk a lot of those investments, hence things like incubators and joint innovation projects, RD&D funds, and the like. And then really understanding that the type of work we say kind of ecosystem developers or innovation ecosystem supporters through clusters and incubators and accelerators are great nests or pipelines into those funds. It's not necessarily you're doing all the due diligence for them, but that if you're part of that sort of network, you come with kind of a lot of wraparound services and support. Next slide. So, we're looking at, why invest and fund in the blue economy, and we're telling that story all the time. When we define the blue economy, it is everything from ocean tech and conservation, tourism, to maritime and shipping, fishing, and seafood. But there's this vast amount of enabling technology and infrastructure that supports all of that. Incredible amount of interdependence and technology crossover that can happen. So, you're entering into multiple markets at one time, and the need for that is growing, through consumer demand. Again, the convergence between those maritime and ocean sectors. Abigail talked great about the global regulation, as well as regional markets are being pulled by regulation. The incredible reduction in technology costs that's happening right now, especially if you're talking about decarbonization and battery technology. And more, this is a cooperative effort really across the globe. And we'll talk more about the partnerships that are building globally around the blue economy too. Next slide, please. And as diverse as the blue economy is as diverse as the money will need to be, right? I mean, there are multiple ways to fund everything from public infrastructure projects to startups to digital, whether it's debt or equity, federal grants, state grants, philanthropic dollars, impact investing. We're going to need all of those different flavors of dollars in order to really grow the efforts of the blue economy we're talking about. And they're starting to pay attention. Next slide. I guess I might say, back there, I put in a little note about economic recovery at the time. We thought this was a good idea a year and a half ago. It's even a more important and pressing idea now. When we're talking about needing to bring capital, everything from infrastructure to jumpstarting new jobs and job creation, now is exactly the time to be doing that work. It's even more pressing now, and so we're at the head of that work. So in order to kick this off, we ran our first pilot Maritime Blue Innovation Accelerator. It was a 4-month acceleration program. It took no equity, and we went out to the world. We really wanted to focus on diversity. When we started putting this together, we thought, well, what should it be? Should it be decarbonization? Should it be underwater noise? Should it be conservation, digital technology? What should it be? And we said, well, you know what, let's just see what's out there and let's attract the interest of as many people as possible because it's so nascent in this space. So we chose these 11 companies, and they were really as diverse as it is. This is Sustainable Seafood Snacks, a maritime battery a storage company, a digital solution for drayage truck drivers, maritime health, conservation technology, really diverse in all that it was, and as well as these are companies looking for, you know, early seed dollars as well as ready for a $20 million Series A round. Next slide, please. We never really imagined the success that we would have, even that about halfway through we went into pretty much total lockdown here in Washington State and around the globe in so many respects. So we shifted to virtual. They all were based here in Seattle. We went virtual. We had over 100 applications when we put the recruitment out. We chose 11, most of them from the US and Washington State. But what we were looking for certainly is the ability for these companies to grow and create markets and jobs and drive capital. We were hoping and looking for them to do that certainly in Washington State, if not King County, surrounding Seattle, kind of for the economic development opportunities that come there, but also that they were solving problems that our industry is facing, right? So we had a couple of companies from outside Washington State, one or two from Canada, one from BC and the other one from Halifax, that were solving problems that we had here. So that too pushes forward our state strategy for the blue economy. We wanted to really focus on as much diversity as we could, knowing that that's a challenge in kind of the founder space. But we did have 3 women founders and 3 people of color who were founders and co-founders of our companies. Our showcase event we intended to do live. We thought we would be excited to have 100, 150 people show up into a room and serve them cold chicken and warm beer, but we had to go virtual. And we had over 500 people registered and 350 unique attendees, which was tremendous for us. So we're really learning, I'm sure as many of you are, how to now do this both virtually and in person. And the wins were staggering. We've got angel investments, Series A rounds, incredible amount of growth in customer contracts and revenue reported. Next slide. What we're trying to do now is build what we're calling the hub and spoke model. We feel like all maritime puns are appropriate. We are recently got an award in order to support continued operations and growth in this space. We're opening this year alongside the next cohort of the Seattle Accelerator, a Tacoma, Washington-based incubator program. So a little different style program. Be focused on the shipping and logistics sector. Could be everything from water quality to digital solutions, but all focused on supporting the shipping and logistics sector in Tacoma. And then expand that across Washington State in this hub and spoke model where the state cluster organization, again, is that hub or nest that each of the spokes can feed off of and to. And of course, we want to do that in further partnership with this whole innovation ecosystem that we've been blessed to be a part of. Next slide. Because we're part of something much bigger here. We're doing great work here in Washington. We're proud of it. We know it's tied to an entire global network. On any given day, we're talking to our friends in Norway or San Diego or Halifax or Singapore, sharing resources, best practices, models, access to capital. Hey, I've got this company here. They just went through our program. We feel like it's a great fit for what you're trying to do there. Great opportunities for us to support portals or access to funding. Great opportunities for us to help set a common standard for impact investment in the blue economy. What does that mean for those kind of impact-based investors and to grow this work together? And that is what's happening. I think next slide is some contact information. Happy to answer more questions and would really just encourage you to be paying attention online in our social media. We're about to release the next recruitment cycle for our Seattle Accelerator, plans for our Tacoma, and some events that go along with that. So I appreciate the time. Thank you. Answer any questions and we'll stick around for a bit.
Thank you very much, Joshua. This is not the first time I hear about this initiative in the state of Washington, but I'm always impressed by the clear vision and a very structured approach to promote innovation with so many partners. And I'm also impressed by how fast this is making progress. I mean, I'm learning new stuff every time. I had a COVID question for you, but you answered it during your presentation. Looks like you're doing well at the moment, that the projects are not negatively impacted. Maybe I would be wondering about the funding, because you mentioned that you were like a pipeline to help these projects and developers find funding. What do you think will happen with this funding because of the current crisis? Mm-hmm. And do you foresee a longer term impact that could be actually positive, considering that the calls for green economic recovery?
Mm-hmm. Yeah, no, I think that's exactly right, David. I mean, I think at the outset of this, there was, clearly a really fast retraction of capital moving, with just the uncertainty and the crisis at hand. I don't think we've solved any of the certainty issues, but I think what we do know is this is going to need to be a concerted recovery effort. So certainly from a public, so wearing my Department of Commerce, State of Washington hat, certainly our perspective is, we're going to use capital funding and infrastructure dollars to support this kind of growth. We know it's going to be we're going to have to do that in a public-private way. We're going to have to leverage outside dollars. From a fund manager's perspective, of which I'm not, I'd be in a different role if I was a fund manager, but to my fund manager friends and contacts, they too are recognizing that they're part of this economic recovery, and they need their capital to flow as much as we need it to. And so they're looking for those sound investments. They're looking towards building back blue or green or better, or however people are talking about this, but that's going to be necessary. And so those kind of what we're calling impact dollars are starting to move, and it's becoming less and less the best kept secret, the opportunities in the blue and ocean economy.
Mm-hmm. Well, that's great to hear, and congratulations again on your recent progress. So we'll move on to our third speaker, who is Jil Hardy, a certified professional engineer, graduated in electrical engineering from Quebec University in Rimouski and Quebec Institute for Electrical and Energy Engineering. Working in applied research at OVATION Maritime, he's interested in reducing the ecological footprint of the maritime industry by optimizing electricity networks and control strategies currently used in the field. And that's what his presentation will be about. So Jil, you have the floor.
Thank you, David. First of all, I would like to thank GreenTech for having me today. And for legal reasons, I have to point out I'm not yet a certified engineer. I'm undergoing the process, and it's going to be done in a couple of months. So, well, thank you for having me today. We'll talk about how we could use batteries aboard for short sea shipping and see how we could minimize the ecological footprint of short sea shipping on the St. Lawrence. Next slide, please. The outline of the presentation is pretty simple. We'll see who is Innovation Maritime. We'll talk about the objective with the project I'll be presenting today. We'll see the basic problems which started everything. And we'll talk about the basics of battery energy storage system, and we'll finish with the preliminary results of our case studies we have undergoing right now. Next slide, please. So, who is Innovation Maritime? Well, we're located in Eastern Quebec. We're a nonprofit applied research center dedicated to the maritime sector. And we value our partners because we need our partners, industrial partners, in order to realize our projects, because we want to have an impact on the maritime sector. So we try to share knowledge and transfer technologies. Next slide, please. And we have a couple of fields of expertise, and we have three departments inside. We have logistic departments. We also have a computer science department, and last but least, we have a marine engineering department, which I am part of. Next slide, please. We are currently undergoing a 5-year program, which is called REVOS. The program covers 6 axes, which we see on the slide. So each green arrow is a project. We have a marine generator in our laboratories, so we do projects on scrubbers and biofuels right now. We're also looking at renewable energies aboard ships, which is solar and wind energy. We are developing a thrust sensor in order to map more adequately the efficiency of a ship. And we're working with an alternative technology which aims to reduce fuel consumption. And last but least, we're also looking at energy storage, which will be what we are speaking today. Next slide, please. A big shout out to our program partners. Without them, it would be impossible to have the leverage in order to do this research. Next slide, please. For the energy storage and load clipping objective, ultimately, we want to find viable cases where we could use batteries aboard ship. And when I mean viable, I mean economically and ecologically as well. In order to do so, we are developing diverse simulation tools. We'll see later on why batteries are a bit of a challenge to size and why we can't do it well strictly on paper. And there also are issues with standard generators and your power management system aboard ship and using batteries, because batteries, well, they can run out of energy. So we're speaking more of an energy management system. And in order to have a complete simulation of an electrical network on a ship, we need to develop a novel controller. And this simulation will be validated with scaled down marine electrical network attachments, which has the same which acts as the same as a normal ship, but it has much lower power. Next slide, please. Why are we looking about adding batteries on ship? Well, there are challenges for standard generators aboard ships. If we're talking about the St. Lawrence, there are redundancy issues because we need to have an idle generator along with the power takeoff. Let's say we have a ship with the mechanical propulsion with the power takeoff. And also, the biggest issue is resize generators for the worst case scenario. Hopefully, we are not always in the worst case scenario during normal operation, but this leads to underperformance issues. Next slide, please. And when we're not in our performance areas, because mainly we have low loads on the generator, when we have lower loads on a fixed speed generator, there are issues because there is a lower internal temperature, which leads to more global emissions, inefficient use of fuel, and these mechanistic issues listed over here. Next slide, please. The basics of batteries, it's pretty simple. You have your batteries, which are direct current, and then at the end, you have your electrical ship network, your ship electrical network, which can be alternating current or direct current. And in between, you have power electronics in order to adapt the waveform, the amplitude of the voltage. You'll notice there is no shore power diagram on this slide because in Quebec, it's not that popular right now. And it's a shame because it would be a great way to reduce greenhouse gases emission. But this is a subject for another day. Next slide, please. There are pros and cons to power electronics. They are very efficient, but we have to keep in mind, since in this presentation, we're not talking about shore power, the batteries are charged with diesel generators, which leads to less emissions in operation. Why? Well, if we have a generator which has a low load, we can use the battery to add more load to it in order to reach our performance area. If you look at the figure on the right, it's the speed characteristics of a generator when you apply a load to it and you remove it. When we talk about generators from 1 megawatt to 1.25 megawatts, we're talking maybe about seconds in order to synchronize with the electrical network. In comparison, the power electronics, we talk about milliseconds. They are much faster and can help for the health of your electrical network, which is the case for wind power plants, let's say. They need low maintenance because it's all solid state electronics, no moving parts. They are reliable and proven in other industries, such as the mining and paper industry. And there are low mechanical vibration related to it compared to a diesel generator. Next slide, please. There are challenges, though, in order to use the batteries on ships. The battery life cycle and sizing is one thing. Just having your batteries on the shelf, they are aging. And the battery packs we have right now have a 10-year lifespan, and our gensets, diesel generators, have 20 to 25 years lifespan. So we have to consider this while doing a concept. They can be green, but it depends on how to charge them, and it depends on your diesel generator. So we have less emissions, but we still get emission from using batteries. It's not a miracle solution. As I said earlier, you need a better coordination between generation systems, compared to classical generation systems. They're quite costly right now because there is demand for the market, but not as much as it should be in order to reduce the prices. There are thermal management issues. There are risks of explosion. Hence why we use battery management system in order to have the good health signal to manage them. And the harmonic distortion is what you see on the figure on the right. Since we have power electronics, they are nonlinear systems. What you want on your ship is the gray line. Power electronics generate the black line. And when we add them together, well, you get more voltage at your equipment terminals, which can be a problem. It can be managed, but these are design considerations. Next slide, please. For the case studies, well, the biggest challenge for case studies for us right now is the data challenge. Most of the ship owners have power management system on board, and they can gather data, you know. But if we have the power flow, that's a good thing. But we also need to know in which scenario we are having this power flow. Are we unloading? Are we seagoing? Are we canal going? And this is the issue right now, because in order to size a proper battery bank on a ship, we have to get very accurate data in order to do an appropriate sizing, because it's easy to just add too much batteries and have an acquisition cost which is not normal, and we can undersize, which lead to safety issues. So we'll be looking at the preliminary results of a self-unloading bulker of one of our partners. We looked at two scenarios. We checked for a retrofit installation where we could add a small battery bank on board just for black starts and when canal going in order to shut down the required idle generator. And we'll also look at power generation reconfiguration for new builds. Next slide, please. Which is mostly like, it's inspired from what we do with ferries, some ferries right now. So we removed one diesel generator to add the battery bank, and we oversized a little bit one, and it's an okay trade-off. Next slide, please. It's an okay trade-off because if everything's going well, it's optimal. But if you have one auxiliary generator breaking down, it leaves you with this scenario, this particular scenario, with only 1 hour of power. But these are written on paper, and that's why we're developing simulation in order to optimize everything. So the results show that there are savings we can do with global emissions, but the payback is not that interesting right now because of the prices of diesel, generator sets, battery, and power electronics. hopefully, the program is 5 years and we've been 1.5 years through, so we'll find more interesting cases. And the conclusion here is that for self-unloading bulkers, adding batteries is not the miracle solution in order to meet IMO 2030 and IMO 2050. When we're speaking as of today, the market can move, there might be more shore power in the future, which will help with the use of batteries, but the scenarios are difficult to work, and we still need to invest. Next slide, please. So in conclusion, the problem we have with short sea shipping, one of the problems we have right now with short sea shipping is the underperformance issues of the auxiliary generators. Battery and power electronics have pros and cons, and they are proven in other fields than the maritime sectors. And it's still new in the maritime sector, so it's a good time to look into it and build up scenarios which could be interesting. And last but least, refinement through completion. We have preliminary results, and I hope that in 3.5 years I'll have a solid case to present to you and show you how batteries will be interesting for the market. But right now we can't say so. It's a work in progress. Next slide, please. So thank you for having me, and I hope you learned a thing or two about batteries on the short sea shipping today.
Thank you very much, Jil, for sharing your project, your progress on this research. It's interesting to see that you're working with 3 Green Marine certified companies on the St. Lawrence River, very different types of companies from bulk carriers, as you mentioned, to ferries and tugs. So I can imagine that the challenges must be very different from one type of vessel to the other.
Oh, yeah, definitely. It's mostly about the operation profile. And they're very different depending on the ship, even if they're 2 self-unloading bulkers, you know, depending on the route and many specifications.
We have questions from the audience. Our colleague and naval architect, Eleanor Kirtley, could the thrust sensor be used, for example, to measure the efficiency benefit of hull cleaning, like the on-the-go hull cleaning device that Abby introduced?
This is not my project, so I'm not that deep in the details, but I guess so. If your hull is dirtier and you need more thrust in order to move on, well, definitely the thrust sensor would be able to give a difference if you clean your hull after and you measure the thrust you need in order to add this.
We have another question from Christian Nadeau. Was the reduced maintenance for avoiding to run a second generator considered in the payback economies, or just the fuel cost avoided?
We are working on developing a solid metric on it, because we know what are the mechanical issues related to it, but we need to have an economic metric added to it. And if you have any cues or input where we could find that, that would be very appreciated.
And then a question from Hugo Daniel. What could be the additional annual cost of maintenance due to the 2 generators operating below their optimal operational point?
That's a very good question, since we have not developed yet the metric in order to economically measure that. But I've talked to a fisherman which has an idle generator running most of the year, and he breaks 1 time a year, whereas he could break less often if it would be more appropriate to the load he's using. But still, there are safety issues, and it's important, you know, to oversize sometimes.
And there's a last question, something that you mentioned but then tried to avoid during your presentation. You mentioned shore power isn't that popular in Quebec right now. Why is that?
It's a complicated question, because, you know, we're lucky in Quebec to have hydroelectricity, which is cleaner than burning diesel. But it's mostly coordination issues, I think, between ship owner, ports, and the government. If there would be more incentive from the government in order to move on with these installations, there might be more shore power right now. And we have a project which will be starting soon in order to evaluate more clearly why isn't there more shore power in Quebec right now.
Well, you can talk to Abigail after the call, after the webinar. But thank you very much, Jil, for your presentation and for answering all these questions. So let's move on. Last speaker today, but certainly not the least, is Joseph Williams, who has over 25 years experience as a president and CEO of 3 hydrogen on-demand companies. Prior to that, he's had years of experience in different sectors, such as banking, management consulting, retail, grocery trade, and hospitality. Joseph is a 2-time former Manning Award nominee and patent holder of a hydrogen injection device. So Joseph, the virtual floor is yours.
Thank you very much. And I want to thank all the previous speakers. Very, very informative, and I learned a lot, and I appreciate what everybody's trying to do to better the planet. So thank you. So I'd just like to speak briefly today on hydrogen demand technology. Some people consider it a new technology, but it's actually 46 years in the making to where it has become a very viable transitional technology to allow battery technology, to allow electrification, to allow natural gas, to allow pure hydrogen to become a reality. Next slide, please. So this is just a picture of me many, many years ago. I don't look like this now. I've had 26 years experience in hydrogen on demand, and it gives you the odd wrinkle. Next slide, please. So what we're talking about is the introduction of small amounts, or better yet, fragmental amounts of hydrogen and oxygen gases that are introduced to the combustion chamber of any internal combustion engine. Now, where we get our lift and what all the benefits that we have really are a result of us making more productive use of the existing fuel source. And we've all heard of unburned hydrocarbons, the black smoke you'll see in a garbage truck or a bus. Well, we burn that waste in the combustion chamber. So that gives us greater thermal efficiency, a more complete burn of whatever fuel we're using, whether it's natural gas, whether it's propane, whether it's gasoline or diesel. We'll increase the fuel mileage because we're burning this waste now, and we'll reduce the emissions. So this isn't Joel Williams just telling you that this is what happens here. Many independent studies going back to the 70s have validated this. Next slide, please. The question, however, and it remains today the question, how do we deliver this hydrogen in a safe, efficient, and reliable manner? Reliable being the key word. Next slide, please. So what I wanted to talk about was the evolution of hydrogen on demand with third-party validations and verifications. I'm going to go through a sequence of tests that have been done in the past 46 years to bring us up to where we are today. And it started back in '74 at the Jet Propulsion Lab with Hausman and some other individuals who did on-road studies with fragmental amounts of hydrogen and oxygen gases that we presently use. And that's how we end up getting the name of our technology, which we call the IFI. It's innovative partial hydrogen injection. It's an engineering term, not really a marketing term, but other things like iPhones and iPads, they seem to have done okay, so we feel pretty comfortable. Next slide, please. In the early 80s, I met a professor of dynamics and a Canadian inventor, George Vosper, from Queen's University. And he really taught me an awful lot because I knew absolutely nothing and was dangerous at that time, what a small amount of hydrogen would do to when you add it to the intake of a gasoline engine. It burns 9 times faster than gas, 14 times faster than diesel. Next slide, please. In 1995, further studies done at the University of Birmingham just wanted to show this is a global technology that's been tested and validated everywhere throughout the planet. Next slide, please. So these studies and the other research done on hydrogen, they called it and then a supplemental fuel, but it's not really a supplemental fuel or an alternative fuel. It's fragmental amounts of hydrogen. Next study, please. And a lot of these devices that they had that never were commercialized because of the reliability issues. there are places like the Arizona Department of Environmental Quality, California Environmental Engineering. I was actually involved in the 2004 test that they did, and they did one in 1994. And the result gave a Canadian company, ETV verification, by the way, and they felt that this result really verified that this technology is viable for reducing emissions and fuel consumption in large diesel engines. Next slide, please. The American Hydrogen Association again did testing. The Corrections Canada did testing. Testing was done at the Bowden Penitentiary with Ernie Hughes when he was the head of Corrections Canada, and they got fabulous results to the point where they were granted the CSE Environmental Award back in 1998, I believe. Next slide, please. So as a result of what happened at Bowden, you had the Northern Alberta Institute of Technology. Were testing. They were testing on a Ford Crown Victoria. University of Alberta. They finished accredited courses outlining testing methodology specific to hydrogen enhancement. And Queen's University got on board with some research in the hydrogen fuel combustion when we retained Wardrop Engineering to help us design, develop, and crystallize an onboard generator of hydrogen and oxygen gases that would be reliable, user-friendly, and work in 4 seasons. Queen's helped us quite a bit there. Next slide, please. Recent studies, one in Michigan in 1982. Again, it was hydrogen aspiration in a diesel injection engine doing the same kind of things we did. And what it did in reducing particulate matter, nitrates of oxides, and fuel. Next slide, please. So this is explaining what those studies did. And in the next slide. The goal of the study was to observe the impact of hydrogen injection on engine performance and emissions. And because you'll be getting a PDF of this file, you can read some of the numbers that you'll see in the different tests that were done that are very similar by application, and won't get into detail with them for the shortness of this presentation. Next slide, please. And this is showing the numbers, and some of them are very interesting. Some of them really get into what bad competition will do to you, because what is important to note is CO2, which is greenhouse gases, and fuel economy. They pretty much have to be the same as they are in this test and in all the testing we have done. So if you get 2 different results from CO2 and fuel, that means you've had faulty equipment, faulty testing, or it's just absolutely fraudulent. Next slide, please. And again, this is a study that was done in 2012 in India. It's a really good study. It's worth taking a look at to show what fragmental amounts of hydrogen will do again. Next slide. And then, and this is again another test that has all the different numbers, which are very reflective of what our results are in the studies that we did with the IFI technology. Next slide, please. So the conclusion of all of these studies, not just both, is the use of hydrogen enriched fuel induced in a diesel engine produced less pollution, better overall performance in diesel compression ignition engines. Next slide, please. So the IFI system, when we did our first study with Clean Air Technologies, CADI, we did an on-road study and showed a 30.9% reduction with a highway rig and a controlled test, and city driving, different application, 13%. This is with transportation. We'll get into marine shortly. And we reduced greenhouse gas emissions significantly. Of note, particulate matter, 86%, and NOx, almost 24%. In these studies, which are very similar to other studies that we've done and are really, really important when we talk about what's going on in the world today with COVID-19 that I'll get into in the last slide. Next slide, please. So the CADI people, they conducted extensive on-road tests with Wardrop Engineering in showing what our technology will do, as well as doing testing with West Virginia, Pennsylvania, Transportation Institute, Northern Carolina State University, and CARB. They do a lot of work with CARB now under the name of 3DAX Corporation. Next slide, please. In 2011, the province of Ontario they paid Global MRV to do a third-party study on garbage trucks, recycling trucks. So it was a 120-day evaluation, different duty cycle than transportation or gen sets or marine, but still showed a 30% reduction in PM, 38% or NPM, 29% in NOx, and a 7.2% in fuel. So next slide, please. So this is just a slide showing that the former McGuinty Liberal government, province of Ontario recognized hydrogen injection in its Ontario Green Commercial Vehicle Program. And why this is significant to us is we wrote the criteria for one of the consultants for this. And so that the province didn't want to get bit in the butt with approving a grant and then it coming back on them. So we wanted to make sure that it was safe, and it was safe. And that's the criteria was built around safetiness and other criteria that one would want. That's something that lasted more than a week. And next slide, please. So what we're doing here is we're adding hydrogen and oxygen gases to the air intake of any internal combustion engine, and we fragmental amounts, 1%. Next slide. It burns faster, so it's spreading the flame faster and producing a more complete burn of the fuel in the combustion chamber. Next slide. Burning more fuel increases the distance we're going to travel because we're burning the unburned hydrocarbons. We're burning the waste. Next slide, please. We're burning more fuel. It results in less soot and other pollutants. Soot, the #1 killer to the transport industry. It's also a huge, huge issue with the U.S. Navy, who we're working with Fairbanks Morse right now. And that's one of the big things that benefits that they see is it'll reduce the amount of maintenance that's going to be required on their engines by getting rid of that soot buildup. Next slide, please. Less soot extends the life of the EGR valves and decreasing maintenance costs for in the transport sector, and now in other industries that are required to have the DPFs and EGRs and whatnot. Next slide, please. We reduce and move out the frequency of the diesel particulate filter, saving time and money. Winnipeg Transit, Halifax Transit, most transit authorities in Canada and in the United States, they're spending $18,000 to $22,000 per event every time they have to do something with that diesel particulate filter. It is the nightmare of all nightmares for trucking companies. Next slide, please. So the marine industry accounts for about 3% of the total GHGs. You've got the 2020 IMO regulations in place. We've done limited testing, but the testing we've done on propane, gasoline, and diesel, we brought SO2 levels down to 0 parts per million. Increasing emission regulations reduces the profitability that everybody listening to this knows. In an already low margin, high saturation industry, it's becoming very, very costly. And one hydrogen fuel injection company is positioned for the future. We have a full ISO 14064 Part 2 carbon plan and green print assessment that was performed by Jomini Environmental. And what that is, it's a cradle to grave analysis of the impact of our technology. It's we want to make sure that we can manage. If you can't measure, you can't manage. So we can manage and we can measure the carbon offset reductions. So we can monetize the carbon credits. Next slide, please. So in genset operations, in the marine market that we got into with respect to the Danish Marine Authority, we saved. Caterpillar did the fuel testing. They validated a 26% reduction at 1,800 RPMs. We reduced the maintenance cost. We extend the engine life. The ROI on this, when we talk about ROIs, is less than a year on transportation, on gensets, and on marine. We provide carbon offsets. We create a better working environment. Next slide, please. So we've completed our GPA. We signed a 5-year agreement with Fairbanks Morse that ends in November. We just got a letter from them yesterday. We're renewing that because the Pentagon reached out to Fairbanks and they want us to work on the 3rd contract that we've already won 2 U.S. military contracts with. Lloyd's approval for testing with the Danish Marine Authority are going to also, the Lloyd's group are going to work with us with the US Navy when we do the deployment on the third US contract. Next slide, please. So this is just the slide with the Caterpillar getting showing what the different fuel results are. And again, you'll be able to take a look at this in the PowerPoint. Next slide, please. So we were able to go to Augsburg, Germany at the MAN engine facility. We did modeling on the 4860 engine with the US Navy and Fairbanks Morse using 1% hydrogen. We did 3 and 5. And once we did 3 and 5, actually results got worse. 1% was the sweet spot. No changes to the air fuel ratio. Increases in heat rejection was negligible. So we were not going to void the warranty on a $30 million engine. Next slide, please. So thank you very much for listening to me today. And for any further information, feel free to ask. And I'm so pleased that I was able to talk today. Thank you.
Thank you very much, Joe. Hydrogen is often presented as a potential replacement to fossil fuels, but I didn't know it could be used in combination with current fuels and still deliver interesting emissions reduction. So I think that's definitely interesting as a transition measure. Do you feel that things are finally looking up for hydrogen in the marine industry? Are there still major obstacles? What is required to encourage more ship owners to initiate pilot projects?
Well, that's a really good question. We had a rough time with the COVID, as everybody did. However, the US Navy reached out to us in Fairbanks Morse 1 month ago and want to incorporate our transitional hydrogen technology into their 20-year hydrogen plan, because they really believe their future for fuel with their ships is hydrogen. And so it's not ready yet. And you have to applaud all of the hydrogen companies, the Ballards of the world and other hydrogen. There's still issues with infrastructure and what have you. And that's why we can help make what they're doing a reality by us working with diesel fuel, liquid natural gas. We can reduce the methane slip that happens with liquid natural gas, which is a big problem. So your answer to that is really hydrogen is something that a lot of companies now are looking at for the future. Let's take it step by step. We can help them transition to that.
Interesting. We have a few questions from the audience. So the first one is from Donald McPherson. Do you have figures to quantify net effective heating value and burnable carbon content for the combined fuel?
Yes, we do.
Okay. Second question from Jason Reichert. I think H2 injection is pretty interesting. It could be a great upgrade for older engines or even newer to reduce air problems. I see most of this is short-term or studies. Has this been adopted long-term, more than 5 years of use for evaluation and assessment?
Well, it's personally, we're not going to have like electrification, the liquid natural gas guys and pure hydrogen guys. Ever since they've been saying they're 5 years away, they're 5 years away for an awful long time, 20 years now going with pure hydrogen. It's again, we believe we've got a window, especially with what he said with the old engines. Absolutely. We've got a 15-year window to be able to help other fuel sources and retrofit older engines to bring them up to newer specs.
Okay, thanks. Finally, one last question, which is pretty broad. What is the hydrogen on-demand capability?
Okay, so because of the US Navy back in 2015, we really had to do a lot of work to demonstrate to them that we could design a unit that would fit on a 4860 engine. It's 3 stories high. Now, we had been doing transportation trucks. We did a ferry. We've done the 3412 CAT engine, and then we showed them, and through the modeling, we proved it that we could do this. So there is no capability. It's very scalable, and there isn't anything we can't do. I wouldn't really want to do a nuclear or like a power plant that is so huge and costly, but we still could do it with the money and the proper engineering.
And maybe one last question before we close the Q&A. What are the barriers to broad adoption by ship owners that still exist?
Well, the biggest challenge in the barrier to market to us that we're facing is bad competition. Is you've got guys that I remember being where they were 20 years ago. Like, we were the stupidest company on the planet. We made every mistake that you could possibly made. We were so stupid, we became smart. And so one of the big challenges are the new guys getting into the space that don't understand the science behind the technology. And to me, that's the biggest barrier. The other barriers are all easily overcomable by the proof is in the eating of the pudding. When we put them on, they work.
Okay, so thank you very much once again, Joe, for your presentation and your detailed answers to those many questions. Obviously, this is a topic of high interest. And thank you once again to the three other speakers today for sharing your wisdom with us. And thank you for your discipline with the allocated time. And on this note, we conclude this webinar series that replaced our normal in-person annual conference. Speaking of which, I would very much like to be able to invite you to make the trip to Seattle for our 2021 GreenTech conference, which is scheduled to take place from June 2nd to June 4th. As you can imagine, we're not in a position at this time to confirm whether it will be possible in June to hold an in-person event. There's a definite possibility that our next event will be in a hybrid or fully virtual format. So in a few days, we will send to all attendees of the 6 webinars a short survey to measure your appreciation of this webinar series and collect your suggestions for improvements for future virtual events. Please take the time to respond. This will really guide us in our choices for GreenTech 2021. And I still do hope that we can manage to have some type of in-person event in a few months from now. So thanks again for attending today. Stay safe, and hopefully we can meet in person in the not too distant future. Have a very nice day.